All right, so with all of our examples, we're going to rewrite the expression as an equivalent expression that does not contain powers greater than 1. All right, and the first one we're going to do is sine to the fourth of 3x. All right, so the first few years when we gave the challenge exam, we could see the actual test, and every time they did either sine to the fourth of x or cosine to the fourth of x was on the challenge exam. I couldn't see it last year, so I don't know, but I would guess it was probably on there. So this is kind of an important lesson for the challenge exam. So to use those formulas, they do have to be squared, not to the fourth. So can I rewrite tangent to the fourth as, sine to the fourth as squares? What if I did sine squared of 3x times sine squared of 3x? Would that be sine to the fourth of 3x? Yes. So we're going to use the sine squared formula twice, basically. And in the place of t, we're going to put 3x. So that numerator should be 1 minus cosine of, what do y'all think? 6x. And then 2 in the denominator, and then we'll do that again for the other one. Okay. So that's using the formula. That's not difficult. But what we do next can be somewhat challenging. So we need to multiply these two fractions together. The denominator is no big deal. We're just going to get 4. The numerator, we're going to multiply 1 minus cosine of 6x times itself. So back, at the beginning of the school year, I really stressed the importance of knowing how to square a binomial. And that's what I'm going to do. So I'm going to square the first one, multiply them together, and multiply by 2, and then square the second one. If you don't like that formula, you can distribute 1 and then distribute negative cosine of 6x. It works the exact same way. So I'm going to square 1. I'm going to get 1. I'm going to multiply these together, and so it's just negative cosine of 6x, but then I also have to multiply that by 2. So it's minus 2 cosine of 6x. Then I'm going to square the cosine, so cosine squared of 6x. So whenever you're multiplying or dividing, and we have this cosine of 6x, the only time you can touch the 6x is if you're using some kind of the formulas. So otherwise, you're just multiplying the front of the cosine by it, or you're squaring the cosine. You're not squaring the 6x. And what we're about to do, we're going to divide each one of these by 4. We are not dividing the 6x by 4. We're dividing the cosines by 4. All right, so when we divide 1 by 4, we're going to get 1/4. And then negative 2 divided by 4 is going to be negative 1/2. And then that would be 1/4 again, 1/4 cosine squared of 6x. So have we done what the directions asked us to do? No, we still have a power that is greater than 1. So we're going to get to do this formula one more time. So the stuff in the front, the 1/4 minus 1/2 cosine of 6x, all that's going to stay just like it looks because it doesn't have a power greater than 1. So we'll just leave it alone. And then now we'll use the power reduction formula for cosine. So if you have cosine squared of something, you can change it to 1 plus cosine of 2 times that something over 2. So the only difference between these is the sign. So 1 plus cosine of 2 times 6x, or 12x over 2. All right, now I'm going to do this just with little steps. The more of these you do, you're going to kind of see what's going to happen, but this is the first one you've ever seen, so I'm going to go kind of slow. So I'm going to, inside these parentheses, divide each of these by 2. Then I'm going to distribute that 1/4. All right, so what's left to do? There's only one more thing to do. Yes. And your only like terms are 1/4 plus 1/8. What's 1/4 plus 1/8? 3/8. 1/4 is 2/8, plus another 8 is 3/8. And then everything else just stays exactly like it looks. For us to be able to add cosines, they would have to have the same angle, and they don't. One of them, the angle is 6x, the other one is 12x. So they are not like terms. This is it. This is how we represent our answer. It's just kind of crazy. Like, it looked a whole lot better when it was signed to the 4th of 3x. There must be a purpose. Like, these formulas were created because someone needed them to do something mathematically. It probably looks a lot better the other way. Oh well. It's good for your brain. It's good practice. It's good algebra practice for sure. All right, so looking through all those steps, is there something you're not sure why it changed or why it didn't change? Okay, we're going to do one more. It's a tangent. And it looks like on the tangent that they just took the sine squared of t and divided it by cosine squared of t. The 2's ended up canceling out. So you got those numerators divided, which that's just the quotient rule for tangent. So that works, but luckily the tangent one is on your formula sheet if you need it. Like I said in the past, it was always either cosine to the 4th of x or sine to the 4th of x. There were different versions of the test. So some people got one and the other half got the other one. All right, so for tangent to the 4th of x, just like we did with the sine, we're going to rewrite it as tangent squared of x times tangent squared of x. All right. And then we're just going to use the power reduction formula for tangent, which is going to be 1 minus cosine of 2x over 1 plus cosine of 2x. And then we're basically multiplying that by itself. So if you wanted to, you could have written it as that squared. It works out the exact same way. However you guys want to do it. Now, even though it looks like we should be able to like cancel out the ones and maybe cancel out the cosines, you cannot. They would have, because of the addition, they would have to look exactly the same, and they don't. So we have to just work from here. So on that numerator, I'm going to multiply these, which means I'm basically squaring it. So I'm going to square 1, multiply them together, and multiply by 2, and then square cosine of 2x. And then the denominator will look pretty much the same, just with a plus instead of a minus. All right. And then we're kind of look at this, and we still haven't done what the directions asked us to do, which is make sure there are no squares, no powers that are greater than 1. So we are going to have to do the formula again, or a different formula. But the stuff in the front is fine. Yes. Okay. All right, and again, we cannot cancel because of all the addition and subtraction. We can't cancel that because of all the addition and subtraction. So we can just bring those first couple of terms over, and then we'll use the power reduction formula for cosine squared. And that formula tells you to do 1 plus the cosine of 2 times the angle over 2. This time our angle is 2x, so 1 plus the cosine of 4x over 2. All right, and then we have that again. Now, the challenge exam is all multiple choice, and your choice would never be that. Like, they would never leave a fraction inside of a fraction. But we've been practicing that quite a bit lately. What can I multiply by so you don't have these little denominators too? Yes, ma'am. Oh, it shouldn't. Thank you. So that denominator should be 1 plus 2 cosine. All right, so now I'm going to distribute the 2's across the numerator and denominator. And this last one kind of threw some people off earlier. When I multiply 2 by that fraction, what's going to happen with the 2? Yeah, they're going to cancel out, and you're just going to be left with the numerator. Okay. And then very similar things happen in the denominator. All right, and then finally, we just need to add our like terms, which is the 2 and the 1. And again, because of all this addition and subtraction, I cannot cancel anything, even though it looks so similar. This is the final answer. Tangent to the 4th of x with no powers. All right. Yes, sir.
So why couldn't you like get rid of the cosine for x?
Like this?
Yeah.
Because of the addition. Now, if it had been multiplied by it, you definitely could. But because of the addition, like it's all like bound together, and to be able to cancel, it has to look exactly the same, like everywhere. All right, what other questions do you guys have? All right, you only have 3 problems. They take some time and some space, but I am going to go ahead and give you your reviews today in your new golden stamp sheets. So we're going to do the same exact directions as the examples. Number 1 is cosine to the 4th of x. Number 2 is sine to the 4th of 2x. And number 3 is tangent to the 4th of 2x.